So just remember during this video lesson that if at any time I'm going too fast, that you please ask the sub to pause the video so you can catch up with the writing and actually pay attention to my explaining. Because I won't be taking long pauses like I normally do in class to allow you to write things down. So in today's lesson, this is our last lesson of the unit. We are going to learn to add and subtract rational expressions. So before we actually start working with the variable portion of this, we do need to discuss how to add and subtract fractions. So for example, say you have 1/2 plus 1/2. Then hopefully you know that this equals 1. But why does it equal 1? Well, whenever we add fractions, we keep the denominator the same, and we simply add the numerator. So 1 plus 1 is 2, and 2 divided by 2 equals 1. Now it gets trickier whenever you add fractions that have different denominators, for example 1/2 and 2/3. We cannot just add across the top because the denominators aren't the same. So first we have to rewrite these with a common denominator. And so this first fraction's denominator is 2 and this is 3. So how can they both become the same denominator? Well, the easiest way is to multiply each denominator by the other one. So in this first sorry about that, it froze. In this first fraction, we're going to multiply by 3 on top and bottom. And this fraction, we're going to multiply by 2. And I say top and bottom because whatever you do to a fraction on the bottom, you have to do to the top to keep it the same fraction. So now we have 3/6, which is still the same as 1/2, plus 4/6, which is still the same as 2/3, but now that they have a common denominator, we can add going across the top. So that's the general basics of how to add two fractions. So now let's actually throw in the variable part, the rational expressions. If you open your first tab, we're going to do an example here, and we're going to write our steps right here. So our first example will be x plus 6 over 3x minus 6 plus x plus 1 over 3x minus 6. Notice the denominators are already the same. This whole tab will be like that. So looking at it, the very first step, the very first thing that we're going to do is we're going to combine or add the numerators. So I always say add the numerators. But if you were subtracting, it might be better to say combine. So you just combine them by whatever operation you have here. So when we go to do that, we end up with x plus x is 2x, and 6 plus 1 is 7. So we've added the numerators and rewrite it over our common denominator, just like we did with the numbers. At this point, we want to factor if possible. And the reason why we want to do that is to start looking for any ways that we can simplify. And since these are quantities, we can't simplify unless we factor. If we look at our numerator and denominator, it looks like the denominator can be factored. There's a GCF of 3. So I'll rewrite the numerator, and the denominator becomes 3 times the quantity x minus 2. So we did factor it, and third, you should always cancel any common factors. However, if you look at our numerator and denominator, it does not look like there are any common quantities or numbers that we can cancel. So it looks like we're done. We've added the fractions, we've fully simplified, and now we just have to state any excluded values. So as you can see, a lot like our last lesson, but instead of multiplying, we're adding. So our excluded values here, there's only going to be one because we didn't cancel anything. This is the original factored denominator. So x cannot equal 2. If you need a little refresher on how we find excluded values, you only look at the quantities that have variables. So the 3 doesn't yield anything. If we tried setting it not equal to 0, it wouldn't even make sense, so we'd just cross it off. But x minus 2 does not equal 0. We would add 2 to both sides, and that's how we got this excluded value. And that's it. We're done. Now I do want to highlight a little bit here. The main thing that we learned was that we add the numerators. So highlight that step and then highlight us actually adding the numerators into 2x plus 7. Okay, so that was a really easy problem. Now let's go ahead and we're going to keep common denominators, but now we're going to try subtraction, and we're going to add a little bit more to the steps here. Or not to the steps, but a little bit more complexity to the steps we've already done. So our problem is going to be x plus 2 over 2x squared plus 13x plus 20. I'm going to zoom in just a little bit. Minus, so now we're doing a subtraction problem, minus x plus 3 over the same denominator, 2x squared plus 13x plus 20. So first of all, let me show you how to deal with the subtraction sign, because a lot of students will mess this up. Whenever they combine the numerators, they accidentally only subtract the first term. But really, when you're subtracting a fraction and there's a quantity, you have to distribute that negative. So grab a highlighter, and I want you to highlight that minus sign, change it to a plus, and we're actually going to distribute the negative, which means change the sign on the other terms. And it only gets distributed to the top. And then make a note over here to distribute the negative. If you do that every time you have a subtraction problem, then it'll keep you from making a lot of silly mistakes. Because now we can just treat it like an addition problem. So step 1, we're going to add the numerators. So I'm going to go ahead and combine x minus x, and then actually, x term actually goes away, and then 2 plus negative 3 is negative 1. And my denominator stays the same. Okay, so at this point it says factor if possible. Now we know that even if we factor, nothing's going to cancel with 1. But we still need to factor because of excluded values. I'm looking at this trinomial. I see that there's an a out front, and it doesn't look like a GCF of 2 can be pulled out. So that means we're going to have to do trinomial where a does not equal 1. So I'm going to do this work over here in a little thought bubble, and then I'll insert what I get into my problem. So 2x squared plus 13x plus 20. I'm going to multiply 2 and 20 to get 40. Factors of 40 that add up to 13. You can pause it and think about it. Maybe let the students work this out a little bit. But the factors of 40 that add up to 13, we've got 4 and 10. We've got 5 and 8. 5 and 8 are the ones. And I'm going to put the 8 first. So I'll have 2x squared plus 8x plus 5x plus 20. At this point we've got 4 terms, so we should group, pull out a GCF of the first 2 terms, leaves behind x plus 4, and then pull out the GCF of the second 2 terms, and it also leaves x plus 4. And then lastly, we're going to pull out that common parenthesis and write what's left behind. And hopefully that's what you got whenever you worked it out by yourselves. And so now I can rewrite my denominator as x plus 4 times 2x plus 5. So back to our steps. We factored, but now we need to look and see, can we cancel any common factors? No, we cannot. And so lastly, state our excluded values. Now the first one's pretty easy to just eyeball. X can't equal -4 because that would create a 0 in the denominator. But the next one might not be as easy for everyone. So if it's not easy for you to just eyeball, set up a little mini equation where it's set not equal to 0 and solve it. Subtract 5, divide by 2, and you get -5/2 as your other excluded value. Alright, so that's the first video. That's if you've got common denominators. Now let's talk about what you do if you have different denominators.